Now, what happens when you have multiple radicals or you have x's on both sides of the equation, or x and then a radical with an x? So what we need to do is, in this case, we're going to get our radicals on there on both sides of the equation, and we are going to just square both sides because we want to free what's underneath the radical. So when we square the square root of 2x minus 9, it essentially cancels it out, and we get 2x minus 9. And that's going to equal x. And now you're just going to solve like you would ordinarily solve. So I'm going to bring my 2x to the other side, and I'm going to get negative 9 is equal to negative x. And then I'm going to continue solving by multiplying both sides by negative 1, and I get that x equals 9. Now we should check the solution just to make sure it works. So you always want to plug it into the original equation. So I'm going to plug in 9, and I'm going to get 2 times 9 is 18 minus 9, and it equals the square root of x is 9. And this totally matches. Square root of 9 does equal the square root of 9. So I want you to hit pause, and I want you to try this problem. I'll start by letting you know what the answer is, and then we'll work it out in case you ran into trouble. Now, hopefully, when you've worked this out, you were able to get that y is going to be equal to 3. But if not, let's just go through and see how this all plays out. We're supposed to square both sides because we have our radicals now on opposite sides of the equal sign. So square it and square it. And when you do, you're going to get a y plus 1 on this side, and that's going to equal 4y minus 8. Now this is just like a chapter 1 problem. We're going to get all of our y's on one side. So I'm going to bring this y over here and get 1 equals 3y minus 8. And then I'm going to bring my actual numbers to the other side by adding 8 to both sides. And I'm going to get that 3y is equal to 9. By dividing by 3, I will get that y equals 3. And if you plug it into check, it completely works. So what's a little more interesting, I think, will be to find out what happens when you have x's on both sides, but one is a radical and one is an ordinary x. We're going to end up squaring, and we are going to get phantom answers, meaning we're going to get answers that don't actually work. So let's see how this one works out. Luckily, it's all the same steps. The main thing is you must isolate the radical. It's okay to have multiple things on the other side with the x, but the radical must be all alone. So now we're going to square both sides. So I'm going to square it, and I'm going to get x plus 2 is equal to x squared. Now, we're going to simplify and solve, and we're going to check our solution. But first, when you have an x squared and an x, you need to bring everyone to the same side. And I'm going to bring these two over to the other side because I like to factor a positive x squared. So I'm going to minus x and 2 from both sides. And I'm going to get 0 equals x squared minus x minus 2. Now, what two things multiply to give you 2 and subtract to give you 1? Well, hopefully you got 2 and 1. And so we're going to get x and x. We're going to get 2 and a 1. And we want the this middle term to be negative, so we're going to get a negative. This one is a plus. It's still all equals 0. What would it take to make this equal 0? Well, x should be 2. And what would it take to make this parentheses 0? That would be a negative 1. Now, both of these are not solutions. So if we go back to remember, the other side of the equal sign needs to be positive. Let's go back to our original equation. I'm going to get rid of these little squares. And we're going to start from scratch. Square root of x plus 2 equals x. We need this side to to be positive. If we plug in 2, everything's great. But if we plug in -1, it does not work. And if you try it out by plugging in -1, you'll see that the answer doesn't come out to be true. If you check it out, the square root of -1 plus 2 equals -1. You're going to get the square root of 1 equals -1. And if you remember, when the square root is actually already there, we're looking for the principal root. We're looking for the positive root. Square root of 1 equals +1. And it doesn't equal -1. So that's why that is not actually a solution. Now you should try the next one just to see what you get for your answer. So hit pause and see how that works out. Check your answer. And then the super sneaky problem has a video with Miss Ralston, a former math teacher, working a problem out like this. Hopefully you got x equals 3 as your answer. This one, because it worked out to be a perfect square, it doesn't have a phantom answer, because if you did this correctly, when you factored it, you got x minus 3 times x minus 3 equals 0, giving you only one solution. So you didn't even have to worry about the phantom answer. Check out the other video for how to do the super sneaky one if you run into trouble.